In the Atlantic in early 1944, anti-submarine warfare is no longer driven by search, but by arithmetic. A Type IXE submarine enters patrol with finite, measured reserves, approximately 11,000 ampere-hours of usable battery capacity, compressed air reservoirs charged to roughly 200 bar, and a pressure hull whose elastic limits degrade measurably after repeated excursions beyond 180 meters. These are not abstract constraints. They define how many seconds the boat can maneuver at 6 knots, how many minutes it can hold trim under asymmetric flooding, and how many hours it can remain submerged before chemistry, not enemy intent, forces exposure. U-505 departs into this environment already burdened by cumulative stress. Previous depth charge attacks have not breached the hull, but they have altered tolerances. Valve seats no longer seal evenly. Cable insulation shows microfractures. At 30 meters, leakage remains negligible. At 150 meters, the same defects emit liters per minute. The controlling limiter is hydrostatic pressure, because pressure increases linearly with depth while pumping capacity remains fixed, turning minor damage into a progressive system tax. On June 4, 1944, Task Group 22.3 operates west of Cape Verde under Hunter-Killer Doctrine. USS Guadalcanal, CV-60, coordinates destroyer escorts USS Chatelaine, D-149, and USS Pillsbury, 133. Their operational constraint is not firepower, but contact continuity. ASTIC sonar aboard Chatelaine maintains effective detection within approximately 1,200 meters, but a thermocline at roughly 60 meters refracts sound unpredictably. Contact loss exceeding 30 to 40 seconds collapses attack geometry. The limiter is acoustic persistence, because without continuous bearing data, weapon systems lose predictive value. Initial contact is established and held. U-505 dives below the thermocline, cycling between 70 meters and 170 meters to exploit refraction layers. Each depth change requires trim correction. Each correction consumes compressed air and electrical power. At 4 knots submerged speed, propulsion draw approaches 300 amperes. At 6 knots, draw exceeds 600 amperes, reducing endurance to under 6 hours. The technical anchor is discharge rate, because energy consumed at depth cannot be replenished without surfacing. USS Chatelaine closes to Hedgehog launch range. Hedgehog projectiles travel forward approximately 230 meters and descend at about 7 meters per second. Time from launch to potential contact is approximately 30 seconds. Any course or depth change during that interval displaces the impact pattern enough to negate a hit. To avoid this, U-505 maneuvers repeatedly. Maneuvering increases hydrodynamic drag, raising current draw and broadband noise. Noise increases sonar hold range. The constraint is acoustic feedback, because evasion increases detectability faster than it reduces risk. Depth charges follow. Near-miss detonations at set depths around 150 meters generate pressure impulses sufficient to deform battery plates and crack insulation without breaching the hull. Seawater intrusion into lead-acid cells produces chlorine gas within seconds. Compartments must be isolated. Isolating one battery group removes approximately 50% of usable capacity instantly. The limiter becomes remaining kilowatt-hours, because endurance collapses regardless of tactical skill. Atmospheric degradation accelerates. CO2 concentration rises above 2% within hours. At 3%, cognitive reaction times lengthen measurably. Fine motor control degrades. Scrubber chemicals absorb CO2 at a finite rate and saturate. Regeneration is impossible while submerged. The controlling constraint is crew functional time, because procedural reliability degrades before mechanical failure becomes visible. Flooding remains controlled but cumulative. A leakage rate of 4 liters per minute adds more than 240 kilograms of water per hour. That mass shifts longitudinal trim by degrees. Each correction consumes compressed air. Reservoir pressure falls from approximately 200 bar toward 140 bar. Below that threshold, ballast blows become incomplete and asymmetric. The limiter is minimum effective air pressure, because without it, controlled surfacing cannot be guaranteed. U-505 surfaces abruptly. The ascent is forced, not tactical. Surface speed peaks at approximately 10 to 12 knots due to propulsion impairment and hydrodynamic drag from compromised fittings. Destroyer escorts sustain speeds above 20 knots. Escape geometry collapses within minutes. The technical anchor is surface speed differential, which closes all maneuver options regardless of intent. Abandonment follows under compressed timelines. Scuttling charges are placed, but not fully synchronized. Seacocks are opened, but not verified. Flooding begins, but does not reach reserve buoyancy threshold before the crew departs. The submarine remains afloat. The controlling constraint is flooding progression time, measured in tens of minutes, sufficient to allow intervention. Boarding teams from USS Pillsbury move immediately. Hatchways restrict movement to single personnel. Vertical ladders slow ascent and descent. Rising water reduces mobility in stages measured in minutes. Priority is given to radio and control compartments. The limiter is extraction time per compartment, because each minute increases water mass and reduces access. Recovered materials include operational codebooks, short signal manuals, and traffic indicators current for June 1944. Short signal tables compress reports into transmissions lasting seconds. Once captured, they allow reconstruction of intent from minimal intercepts. The constraint governing exploitation is processing latency, because intelligence must be analyzed and disseminated within hours before procedural changes can negate its value. To preserve that window, the capture itself must remain unknown. U-505 is reported sunk. Survivors are isolated. Radio silence is enforced. The submarine is towed at approximately 7 to 8 knots to limit towline tension and hull stress. Higher speeds risk oscillatory loads sufficient to snap lines or tear fittings. The technical limiter is mechanical load tolerance under tow. As exploitation proceeds, ASW operations shift from contact-centric to schedule-centric control. Battery endurance models derived from U-505 logs show that a Type IXE depleted to 35% capacity requires at least 6 hours of uninterrupted surface charging to regain tactical mobility. Under air patrol pressure, uninterrupted intervals fall below 40 minutes. The controlling constraint is minimum recovery block length, because recovery below that duration never restores usable margin. Air patrols are timed to intersect predicted recharge windows every 60 to 90 minutes. A single radar contact forces a crash dive within 180 to 240 seconds. A crash dive consumes approximately 4 to 6% battery capacity within the first 300 seconds due to high-speed descent and trim stabilization. The limiter is recovery negation, because one interruption erases multiple short gains. Surface escorts exploit the same arithmetic. Holding sonar contact for 15 to 20 minutes denies both recharge and atmospheric normalization. CO2 rises at approximately 0.4 to 0.6% per hour under low ventilation. Atmospheric recovery requires longer than the denial interval. The constraint is atmospheric recovery time, because it exceeds the pressure cycle imposed by coordinated ASW. Mechanical efficiency degrades predictably. Continuous pump operation increases thermal load. Motor windings heat. A temperature rise of 10 to 15 degrees Celsius increases electrical resistance, raising current draw for the same shaft output. Over hours, this reduces endurance measurably. The technical anchor is thermal inefficiency accumulation. Intelligence derived from U-505 sharpens timing further. Reporting intervals and variance bands allow planners to treat silence as data. Absence of transmission beyond modeled thresholds triggers asset redeployment. The limiter is inference confidence, because when estimates are validated, planners act earlier and closer. German countermeasures trade concealment for endurance. Snorkel use constrains depth to 15 to 20 meters and speed to approximately 4 knots. Mass vibration increases acoustic output. Radar cross-section of the snorkel head becomes detectable at ranges exceeding 8 to 10 nautical miles under favorable conditions. The controlling constraint is vertical maneuver confinement, because regaining energy requires surrendering depth-based concealment. Weather compounds rather than relieves pressure. Rough seas disrupt visual detection but increase mass stress and spray ingestion. Diesel shutdowns interrupt charging. Each interruption resets recovery progress. The limiter is weather-induced interruption frequency, because rough conditions degrade recharge efficiency faster than they degrade detection. Operational outcomes shift. Boats return with torpedoes in used. Periscope exposure time required for firing solutions exceeds safe windows by tens of seconds. Each aborted setup consumes energy without producing effect. The technical anchor is setup duration mismatch. By late 1944, ASW pressure functions statistically. A single contact does not destroy a submarine, but increases the probability that the next recovery attempt will fail. Battery reserve falls below maneuver minimums. Compressed air pressure drops below reliable ballast thresholds. Crew performance degrades below procedural reliability. These thresholds are crossed quietly. The controlling constraint is cascading threshold failure. Command initially treats U-505 as irrelevant. A single captured hull does not alter tonnage curves or convoy schedules, but the capture calibrates models. Estimates become constraints. Constraints become schedules. Once validated, schedules are enforced aggressively. The technical limiter is model confidence amplification, because validated numbers justify tighter pressure without additional forces. At scale, the Atlantic becomes an accounting system. Kilowatt hours are consumed faster than replaced. Bar of compressed air fall below control thresholds. Decibels rise above sonar hold limits. Minutes of exposure accumulate faster than recovery. The ocean remains vast, but the safe operating envelope collapses into corridors defined by arithmetic. In this environment, the submarine does not lose because it is detected once. It loses because recovery becomes mathematically improbable. The capture of U-505 does not introduce a new weapon. It removes uncertainty. When uncertainty is removed, concealment becomes conditional, and conditional concealment fails under repeated cycles. What shifts the war is not the moment of boarding, but the confirmation that endurance, not courage, governs survival, and that endurance can be scheduled, denied, and exhausted with precision measured in seconds. As the pressure regime stabilizes, Allied ASW planning begins to operate on fixed temporal grids rather than adaptive response. Patrol aircraft sorties are slotted in cycles aligned to predicted submarine recovery failures. A Type IXE that drops below 30% battery capacity cannot delay recharge beyond approximately 8 to 10 hours without risking propulsion loss. This creates a narrow temporal corridor. Aircraft revisit that corridor every 75 to 90 minutes. Each pass collapses the probability of uninterrupted recharge toward zero. The controlling constraint is revisit interval versus minimum recharge duration, because when revisit intervals remain shorter than recovery requirements, recovery becomes impossible by design. Crash dive mechanics impose additional penalties. From surface to 20 meters, a Type IXE requires approximately 20 to 25 seconds under emergency ballast flooding. From 20 to 60 meters, another 15 to 20 seconds are required to stabilize trim and arrest descent. During the first 60 seconds, propulsion motors draw peak current to counter negative buoyancy and maintain heading. That minute alone consumes energy equivalent to several minutes of silent running. The technical anchor is emergency descent energy spike, because repeated spikes accelerate depletion disproportionately. Surface escorts coordinate to exploit these spikes. Once a submarine is forced to dive, escorts reduce speed and maintain sonar contact rather than close aggressively. Holding contact for 10 minutes denies the submarine the option to surface immediately after the dive. Holding for 20 minutes forces deeper energy deficit. No weapons are required. The limiter is post-dive recovery window, because a dive followed by enforced depth residence converts a single interruption into sustained loss. Atmospheric chemistry continues to constrain options. At sustained CO2 levels above 2.8%, Error rates in repetitive tasks increase sharply. Valve sequencing errors occur. Electrical switching delays appear. Each small error produces secondary load increases. The constraint is cognitive degradation threshold because once crossed, procedural reliability declines faster than mechanical gauges indicate. Mechanical degradation compounds silently. Shaft vibration increases bearing wear. Bearing wear increases friction. Increased friction raises current draw by tens of amperes. Over a 12-hour period, this additional draw removes several hundred ampere hours from remaining capacity. The technical anchor is friction-induced efficiency loss because it converts mechanical wear into electrical debt without visible damage. Intelligence exploitation evolves further. Analysts correlate U-boat silence intervals with known battery endurance curves. Silence extending beyond predicted thresholds indicates either destruction or enforced depth residence. In the latter case, resurfacing attempts are imminent. Assets are pre-positioned accordingly. The limiter is silence duration inference, because when silence itself predicts future exposure, concealment loses temporal depth. German command reacts incrementally. Reporting formats are altered. Transmission windows are shortened. Patrol areas are shifted southward and westward. These changes increase transit time by days. Increased transit time consumes fuel and provisions without increasing attack opportunity. The constraint is transit overhead accumulation, because time spent moving through contested zones produces no operational return while consuming finite endurance. Snorkel use intensifies but introduces structural stress. Continuous mast exposure subjects the snorkel head to cyclic bending loads. Fatigue cracks develop. Failure probability increases after hours of operation in moderate seas. Each failure forces shutdown and repair attempts under pursuit conditions. The technical anchor is fatigue life of exposed components, because endurance extensions rely on hardware not designed for sustained stress. Weather amplifies these failures. Swell-induced mast oscillation increases acoustic signature. Spray ingestion forces diesel throttling. Throttling reduces charge rate. Reduced charge rate lengthens exposure. The limiter is coupled degradation, because conditions that degrade charging also increase detectability, preserving the net pressure. Operational reports reflect the shift. Boats report fewer firing opportunities. When firing solutions are obtained, periscope exposure required for confirmation exceeds safe limits by 20 to 30 seconds. Each aborted attack consumes energy equal to several minutes of silent running. The technical anchor is targeting exposure mismatch, because weapon effectiveness no longer aligns with survivable exposure windows. By early 1945, ASW success no longer depends on continuous asset presence. A single well-timed interruption can precipitate failure days later. A missed recharge window propagates forward through the patrol cycle. Battery capacity never recovers. Air pressure never stabilizes. CO2 never normalizes. The constraint is delayed failure propagation, because the decisive effect occurs hours or days after the initial interruption. The capture of U-505 remains embedded in this process as a calibration point. Its engineering data validates assumptions about discharge curves, recharge limits, and noise growth under stress. With validation, planners remove safety buffers. Patrol spacing tightens. Reaction times shorten. The controlling constraint is buffer elimination, because once buffers are removed, systems operate continuously near failure thresholds. At scale, this produces a systemic shift. Submarines are not hunted individually. They're scheduled out of endurance. Each patrol begins with a finite ledger. Every forced dive, every interrupted recharge, every denied atmospheric recovery subtracts from that ledger. When the balance reaches zero, loss becomes a matter of time rather than chance. The Atlantic thus transitions into an environment where outcomes are prefigured by numbers recorded days earlier. The moment of contact becomes less important than the sequence of constraints that precede it. What appears as sudden destruction is often the final manifestation of a deficit accumulated in increments measured in seconds and amperes. In that environment, the submarine's greatest vulnerability is not detection, but predictability imposed by physics that no doctrine can evade once quantified. As this regime matures, Allied coordination compresses the timeline further by synchronizing air and surface assets to the same recovery denial clock. Aircraft force the initial interruption. Surface escorts arrive within a window measured in tens of minutes, not hours. A submarine that crash dives at midnight and is held down until 0:20 loses the opportunity to surface until at least 0:40 due to residual sonar presence and repositioning geometry. That 40-minute gap exceeds the tolerance for fragmented recharge accumulation. The controlling constraint is inter-asset handoff latency, because when latency remains shorter than the minimum recharge interval, denial becomes continuous without continuous contact. Engine management under pursuit imposes another fixed cost. Diesel generators at reduced output charge batteries inefficiently due to suboptimal load factors. Charging at 60% rated output restores approximately 1.5 to 2.0% capacity per 15 minutes under ideal conditions. Under pursuit, interruptions reduce effective gain to less than 1% per 15 minutes. Over a 6-hour period, net recovery remains below 10%. The technical anchor is charge efficiency at partial load because efficiency collapses faster than exposure risk declines. Electrical distribution degrades unevenly. As battery banks age and suffer shock damage, internal resistance rises. Higher resistance increases heat generation during both discharge and charge. Heat further raises resistance. This positive feedback reduces usable capacity without visible structural damage. The constraint is resistance-driven capacity loss, because it converts time into permanent reduction of endurance across the remainder of the patrol. Trim and depth control errors increase as compressed air pressure declines. Below approximately 140 bar, corrective blows require longer valve open times, increasing noise and reducing precision. At depth, delayed response causes oscillation of pitch and depth. Oscillation increases hydrodynamic drag and current draw. The technical anchor is control latency under low air pressure because latency amplifies energy consumption during every maneuver. Sonar operators exploit these oscillations. A submarine struggling to hold depth produces characteristic Doppler shifts and transient noise spikes. These signatures extend contact persistence by seconds that matter during weapon run-ins and contact holds. The limiter is signature amplification through instability, because instability transforms marginal contacts into reliable tracks. Crew workload rises sharply under these conditions. Damage control, trim correction, and electrical management overlap. Task saturation increases error probability. An error rate increase of even a few percent produces cascading effects when systems are already operating near limits. The constraint is task saturation threshold, because once crossed, recovery actions generate additional faults faster than they resolve existing ones. Intelligence-driven scheduling continues to remove ambiguity. Patrol planners integrate fuel consumption with battery endurance to predict when boats must choose between attack posture and survival posture. Survival posture dominates. Attacks are postponed. Postponement increases time on patrol without offensive effect. The technical anchor is opportunity cost accumulation, because time spent surviving cannot be converted into operational results. German attempts to adapt by extending patrol duration fail against this arithmetic. Longer patrols require more recharge cycles. More recharge cycles increase exposure events. Exposure events increase force dives. Force dives increase energy loss. The constraint is cycle multiplication, because extending duration multiplies the very events that cause failure. By this stage, the Atlantic operates as a denial field rather than a search field. Submarines encounter pressure not where escorts are present, but where endurance arithmetic predicts exposure. This shifts the meaning of space. A location becomes dangerous not because an enemy is there now, but because the system can arrive before recovery completes. The technical anchor is arrival before recovery timing, because it replaces chance encounters with scheduled interception. The U-505 capture remains embedded as a validation node. Its machinery, Logs and procedures reduce uncertainty band from hours to minutes and from tens of miles to single-digit miles. Reduced uncertainty allows tighter timing. Tighter timing allows fewer assets to achieve the same effect. The constraint is uncertainty bandwidth, because shrinking bandwidth multiplies pressure without increasing force. As losses accumulate, reports show fewer boats lost in direct combat and more lost after prolonged evasion. Survivors describe exhaustion, system degradation, and forced decisions rather than decisive engagements. The technical anchor is attrition through degradation, because systems fail after cumulative stress rather than singular impact. At this point, ASW achieves a stable condition. Pressure is sufficient to deny recovery, but not so intense as to exhaust Allied resources. Escorts rotate. Aircraft cycle. The submarine remains under intermittent but decisive constraint. The controlling limiter is sustainable pressure density, because sustainability ensures that denial can be maintained across months without collapse. In this environment, the submarine's fate is decoupled from any single encounter. Outcomes are determined by the sum of interruptions imposed over days. Each interruption subtracts a quantifiable amount of endurance. When the sum exceeds remaining capacity, failure occurs regardless of location. The Atlantic thus becomes an environment where the decisive variable is not detection, but the rate at which recovery opportunities are removed until the ledger closes. As the ledger tightens, Allied planners formalize denial as a measurable output. Each force dive is logged not as an event, but as an energy subtraction. A dive initiated at 6 knots consumes approximately 4% battery capacity within the first 300 seconds. Holding the submarine at depth for an additional 15 minutes removes another 2 to 3% through propulsion at 2 knots, pump operation, and hotel load. In aggregate, a single interruption costs 6 to 7% of remaining capacity. The controlling constraint is subtraction per interruption, because capacity removed during denial exceeds capacity gained during fragmented recharge. Surface geometry reinforces this arithmetic. Escorts position themselves to constrain surfacing arcs. A submarine attempting to surface must ensure at least 2 to 3 minutes without radar or visual contact to complete valve sequencing and stabilize trim. Aircraft detection at typical patrol altitudes produces a response window of 180 to 240 seconds before a forced dive. When multiple assets overlap, that window collapses below the minimum required to surface safely. The technical anchor is surfacing completion time, because without uninterrupted seconds, surfacing itself becomes a liability. Noise management ceases to be discretionary. As components degrade, baseline acoustic output rises by incremental decibels. A 3 dB increase doubles acoustic power. Even if detection range increases by only hundreds of meters, contact persistence improves enough to deny recovery. The constraint is baseline noise drift, because once drift exceeds masking capacity, silence cannot be restored. Electrical load balancing fails gradually. Non-essential systems are secured, but pumps and fans remain mandatory. As internal resistance increases, voltage sag appears under load. Sag reduces motor efficiency and increases current draw. Over hours, sag removes additional ampere hours without movement. The technical anchor is voltage stability under load, because loss of stability converts static time into endurance loss. Trim instability becomes chronic. As air pressure declines and flooding remains uneven, the boat oscillates around desired depth with a period measured in seconds. Each oscillation requires corrective thrust. Corrective thrust adds noise and draw. Sonar operators exploit these oscillations as predictable signatures. The limiter is oscillation frequency, because frequent corrections amplify detectability faster than steady running would. Crew procedures adapt toward conservation, but conservation has limits. Reduced lighting saves amperes, but increases task time. Slower task completion increases exposure during periscope checks and valve operations. The technical anchor is conservation paradox, because saving energy by slowing operations increases exposure duration beyond safe margins. Intelligence inputs continue to narrow prediction windows. By correlating fuel consumption with patrol leg length, planners estimate when boats must choose between attack and survival within 1 to 2 hour bands. Assets are allocated to those bands preferentially. The constraint is decision window predictability, because when survival choices can be forecast, interception can be scheduled. German command attempts to mask patterns by irregular routing. Irregular routes increase transit time by tens of hours. Additional transit time increases cumulative denial exposure before arrival on station. The technical anchor is transit penalty because irregularity trades predictability for endurance loss without net gain. Snorkel operations under pressure introduce failure cascades. Prolonged use causes exhaust back pressure fluctuations. Fluctuations reduce engine efficiency and increase thermal signature. Thermal plume detection becomes feasible under favorable conditions. The constraint is exhaust stability, because unstable exhaust reveals position while failing to restore endurance adequately. Weather-driven concealment proves unreliable. Squalls reduce visual detection but increase electrical load due to stabilization demands and water ingress management. Increased load accelerates depletion. The technical anchor is concealment cost coupling, because conditions that hide also drain. Operational reporting reflects the systemic shift. Boats describe patrols dominated by evasion rather than attack. Time to first attack extends beyond survivable endurance. The constraint is attack latency, because offensive timelines no longer fit within recovery budgets. At this stage, Allied pressure achieves phase stability. Denial events are frequent enough to prevent recovery, but infrequent enough to conserve Allied resources. Aircraft cycles align with escort rotations. The system sustains itself. The controlling limiter is pressure equilibrium, because stability ensures persistence over months. U-505's contribution remains implicit. Its capture reduced uncertainty in every parameter now being enforced. Discharge per dive, recovery per minute, noise growth per shock, recharge efficiency per load. With uncertainty removed, planners eliminated buffers. Without buffers, submarines operate continuously near thresholds. Near thresholds, small perturbations decide outcomes. The Atlantic becomes deterministic. A submarine entering the field with known capacities and known denial rates has a calculable survival horizon measured in days. Each denial shortens that horizon by predictable increments. The final loss appears sudden only because the accounting is hidden. What ends the patrol is not the last contact, but the exhaustion of margins accumulated across dozens of interruptions, each measured in seconds and amperes, until no combination of actions can restore balance. The historical meaning of U-505 only resolves when viewed across the full span of the Atlantic system rather than the moment of capture. By 1944, the war at sea has entered a phase where outcomes are no longer driven by discovery, surprise, or individual engagements, but by sustained imbalance between consumption and recovery. Submarines still possess weapons, crews, and intent, but intent operates inside envelopes defined by amperes, bar, decibels, and minutes. Once those envelopes are quantified, the contest shifts from hunting to scheduling. What the seizure of U-505 provides is calibration. Before June 1944, Allied ASW doctrine relies on estimates with margins measured in hours and tens of nautical miles. After June 1944, those margins contract. Battery discharge curves align with observed performance. Recharge efficiency aligns with measured diesel output under pursuit. Noise growth aligns with cumulative shock loading. Air consumption aligns with actual trim and damage control practice. When estimates become measurements, planning changes character. Interdiction no longer requires saturation. It requires timing. At the operational level, this produces a decisive inversion. Submarines are no longer lost primarily at the moment of contact. They are lost earlier when recovery fails. A single missed recharge window propagates forward through the patrol cycle. A battery deficit incurred on day 3 determines exposure on day 6. A forced dive lasting 20 minutes on one night eliminates an attack opportunity 2 nights later. Failure is delayed, but it is already determined. The decisive moment moves upstream in time, away from combat and into arithmetic. At the doctrinal level, U-505 confirms that concealment is conditional. A submerged platform is only invisible while it can choose when to surface, when to recharge, and when to ventilate. Once those choices become predictable within tolerances of minutes, concealment becomes a temporary state rather than a persistent advantage. Anti-submarine warfare no longer needs to be omnipresent. It only needs to appear before recovery completes. That principle reshapes escort deployment, air patrol scheduling, and asset rotation for the remainder of the war. At the strategic level, the capture exposes organizational latency as a physical constraint. German command does not immediately alter encryption or patrol doctrine because losses remain statistically explainable. Attrition masks compromise. By the time patterns exceed noise, the corrective actions required would demand disruptive changes in keys, doctrine, and technology that cannot be fielded within the shrinking endurance horizon. Delay becomes irreversible. The system has already crossed the point where adaptation can restore equilibrium. The broader lesson extends beyond the Atlantic. Industrial warfare favors systems that can deny recovery rather than those that seek decisive engagement. When recovery rates are forced permanently below consumption rates, defeat becomes scheduled rather than contested. The submarine war illustrates this with precision. Boats are not defeated by superior courage or singular technology, but by sustained pressure that converts every defensive action into a measurable loss that cannot be repaid. U-505 does not alter the tonnage curve by itself. It is not when the war at sea. What it does is remove doubt. It confirms that endurance, not initiative, governs survival, and that endurance can be modeled, anticipated, and denied with accuracy measured in seconds. Once the confirmation is absorbed, the Atlantic ceases to be an environment of uncertainty. It becomes an accounting system. In that system, the submarine remains dangerous but no longer resilient. Each patrol begins with a finite ledger. Each forced dive subtracts from it. Each interrupted recharge fails to restore it. When the ledger reaches zero, loss follows regardless of location or circumstance. The capture of U-505 marks the moment when that ledger becomes visible to one side and remains invisible to the other. From that point forward, the outcome is not decided by the next encounter, but by the rate at which recovery is denied until denial itself becomes permanent.